Today we're going to see how to solve quadratic inequalities on the graph. So let's take an example of x squared minus 3x minus 18 greater than 0. First we're going to factorize. So we're going to get x plus 3, x minus 6, and that will be equal to 0. Then we're going to make each of these brackets equal to 0. So that will be x plus 3 equals 0. And then I'm going to get x equals minus 3. And x minus 6 equals 0. So then I'm going to get x equals 6. These two values for x are called critical values. These are called critical values, these two. Now we're going to put them on the graph. This is our x, that's our y. We have 1, 2, 3, so that will be our negative 3. 1, 2, 3, 4, 5, 6. So this is our 6. We're going to draw our parabola. These two values, I've said they're called critical values. These are the values where our parabola crosses the x-axis. We have positive x squared, so this is a smiley face. So this is how our parabola is going to look like. Now, we are looking for values that are greater than 0. So we know our values will be above the x-axis, somewhere here. How do we know whether they are over here, or between minus negative 3 and 6, or whether they're greater than 6? So, what we could do to check whether the values of we want to check where our x is. So we're going to pick a value. We'll start from this side, from the left side. We're going to pick a value that is less than minus 3. I'm just going to say minus 5. And we're going to extend the dotted line to our parabola. I know our parabola is obviously going up to infinity. So I've extended it. I've extended dotted line to our parabola, and now I'm going to go over to our y, see where what value for y we're going to get if we had minus 5 for x. So we obviously don't know what it is on the scale because my drawing doesn't show that, but we definitely know that this value is going to be positive or greater than 0. So this way we know that this bit is definitely going to be the values for this, for our polynomial is definitely going to be somewhere here. From the numbers will be less than negative 3. Let's see if we can get anything crossing our y-axis if we picked number 3. So I'm going again extend it towards our parabola, which is going to be down here, and extend over the y-axis. We definitely can see that this is a negative value or value less than 0, which is against what we have up here. This is how we know that it's not going to be the values we're looking for. They're not going to be in this region between negative 3 and positive 6. Let's check values for x greater than 6. So if we pick our value, which is going to be 7, I'm going to extend my dotted line here and then extend it over to our y-axis. This is not very straight, but I'll try to make up for it. So we've got our value. We can see that this is also positive, meaning greater than 0. That's how we know that values from over here are going to be possibly values of our polynomial. So that's how our answer is going to be x is less than -3 or x is greater than 6. And this is our answer. Let's see another example. We have x squared plus 3x minus 10, and this is less than 0. We're going to factorize it and make it equal to 0. Obviously here, no, start again. X squared plus 3x minus 10 less than 0. So we're going to make this equal to 0, x squared plus 3x minus 10, and this is equal to 0. Now we're going to factorize it. So our x's will be x plus 5, and this will be x minus 2, and this is all equal to 0. Now we're going to make these factors equal to 0, so that will be x plus 5 equals 0. Then we're going to get x equals -5, and x minus 2 equals 0, so x equals 2. So these are our two values, and this is something that we'll be calling critical values. Critical values. These are the values where our parabola is crossing the x-axis. So what we're going to do next, we're going to draw a graph. And we're going to have 1, 2, this is going to be 2, 1, 2, 3, 4, 5. So this is our -5. And our parabola is a positive smiley parabola. So we're going to draw it just like this. Now we want to see where about our x values are going to be. We know that our parabola, our polynomial, will be looking at values less than 0. That means that will be below the x-axis. But we still want to know whether it's less than -5, between -5 and 2, or greater than 2. What we're going to do, we're going to extend, we're going to start from the left side, and to pick a number, I'll pick a number -7, and I'm going to extend it till it meets our parabola. So I'm just going to draw this dotted line, and then from there where we meet the parabola, we're going to extend it to our y-axis. This way we can see that our number that is less than 5 has y-intercept of a positive y-intercept, or it's greater than 0. We're looking for something that's less than 0. So we know that this is not going to be good. This is not. Let's look at something from region between -5 or -5 and 2. I'll just pick -3. If we extend it to our parabola and then over to the y-axis, we're going to get, will be below 0, so we're going to get a negative number, or a number that is less than 0. Number that's less than 0. And this is what we're looking for. We want something that's less than 0. So we know that our x is probably going to be here somewhere. We're just going to check if our x is maybe greater than 2. So I'm just going to pick number 3 and extend it up where it meets our parabola, extend over to the y-axis. Again, we see that this time we're getting a positive number, which is also not going to work, just like our number from below, from less than 5. This way, we know our x's are going to lie somewhere here. How are we going to write our answer? We're going to say that x lies between -5 and 2. And this is our answer.